question of how we would detect life on another planet without actually going there is a really interesting one.
Today we have the means to send messages to the planets of other stars. But is anyone listening?
400 billion stars in our galaxy, 50 billion other galaxies. Can we be the only ones? Implausible. In fact, in my humble opinion, impossible.
Ours is a restless species, and in our wanderlust we have explored the Earth and sent probes to look for life on some of the Sun's other planets. But we're also a communicative species, and the way to search for life on the trillions of planets circling other suns may be through communication. If there are intelligent beings out there who want to communicate. If someday our descendants have explored the solar system as our predecessors explored the Earth, might they then venture to the stars and set foot on the soil of an extrasolar planet? Can we sail through interstellar space as mariners of old explored the islands of the sea? Or is it better to communicate by listening for messages from space and sending messages of our own? Any way you look at it, interstellar spaceflight is a daunting prospect. It's pretty roomy out there. If we could shrink the sun to the size of just this single grain of salt, the Earth would be a microscopic grain orbiting it at a distance of an inch, and the orbit of the planet Mars would lie within the palm of my hand. The whole solar system, the arena of wished-for human exploration for centuries to come, would be within the reach of my arms. Yet even on this tiny scale, the very nearest star would be more than 4 miles away, beyond those distant mountains in the background. A futuristic starship might make the trip one day if we could figure out how to pay its titanic fuel bill and how to fire up its engines without frying the Earth in its exhaust. But any way you look at it, interstellar spaceflight is likely to be expensive and slow. But if there are intelligent beings out there on the planets of other suns, we may be able to communicate with them, even if they're too far away for us to visit them. Our own boldest explorations remind us that the stars are far away. The twin Voyager interstellar probes, launched in 1977, surveyed the giant outer planets and are now leaving the solar system. They carry a message, a gold-plated phonograph record containing music and sounds of Earth, for the benefit of any aliens who might one day intercept the space probes. But although the Voyagers fly 50 times faster than a jet fighter, they will take 70,000 years to reach another star. Ever since the Renaissance, when Galileo established that other planets exist, people have imagined that we would one day explore deep space. The astronomer Johannes Kepler wrote to Galileo that, given the right ships and the right sails for space, there will be men who are not afraid of the terrible distances. Actually, the right ships already existed in embryonic form. Rockets began as a form of entertainment for the Chinese, who turned them into weapons for defense against the Mongols. The Italians turned them back into fireworks. By the second half of the 20th century, rockets were being launched that were powerful enough to carry people aloft. In a series of steps potentially as profound as the migration of life from the seas onto dry land, humans ventured into space.
Your new flight plan within the next half hour.
You can see the entire continent of Australia from here. Oh my goodness. Pretty impressive, isn't it?
And we're ZOE, that's good copy.
The advent of spaceflight lent new immediacy to an old question. If we can travel beyond our planet, couldn't the denizens of other planets come here, or be here already?
This signal, according to the space people, is a record of our planet's entire history being played back to us now at this time. We were finally invited aboard one of these spacecraft, and as I was leaving the craft, the commander, Soltec, said, "Soon others of your people will be able to have an experience similar to this."
There were 4 men and 2 ladies aboard this ship. These men wore business clothes like any of us do. The ladies were of brunettes and of a dark complexion. They had light waists, dark skirts, and medium-heeled shoes.
Anyone who spends a lot of time looking at the night sky is likely sooner or later to see something they can't identify. I've seen a few myself. My most impressive sighting was of a V-shaped formation of oval white lights that moved through the sky silently at what seemed like an incredibly high speed. Fortunately, I had a pair of binoculars around my neck, so I was able to get a closer look. And you know what they turned out to be? Migrating birds, a flock of migrating birds, lights from a distant city lighting up their belly to make perfect little oval flying saucers. If I hadn't had the binoculars handy, it would have been a mysterious UFO sighting.
It looked to me like a flying saucer. There was a great big, huge yellow glow outside.
It was a big object shaped round, and then on top of it, it looked like a big cone with lights running down from it.
It looked like a big cigar shape lit from both ends.
Back and forth, up and down, changed colors, and then it just disappeared.
The question is not just what we see, but how we interpret it. To claim that lights in the sky are alien invaders is like claiming that they're angels. It explains everything, and therefore it explains nothing. If we can hold off judgment until we have better information, we can distinguish between dubious and sound propositions and between birds and spaceships. When a real flying object unexpectedly shows up, like this bright meteor which crossed the western part of North America on the afternoon of August the 10th, 1972, or this one which passed over New York State on a Saturday night in the fall of 1992, it typically results in much better pictures and more consistent eyewitness reports than has any alleged UFO sighting. Yet millions of people still believe that UFOs are alien spaceships. Why? Perhaps because we tend to project our deepest hopes and fears onto the sky, imagining that the aliens are warlike and dangerous, or that they're angelic benefactors who've come to save us from ourselves.
Your choice is simple. Join us and live in peace, or pursue your present course and face obliteration. We shall be waiting for your answer. The decision rests with you.
No one has come to rescue us, and it's unlikely that anyone will show up soon. And that fact may be telling us something. That the best way to get in touch with intelligent extraterrestrials is not exploration, but communication. By sending not starships, but electronic signals across the interstellar seas. The idea of communicating with extraterrestrials had been in the air since the 19th century, when scientists suggested that we signal the Martians on a night when Mars passes near the Earth. Their proposal was to dig a giant triangle in Siberia, flood it with kerosene, and set the trenches afire. The Martians would recognize the triangle as a symbol of Euclidean geometry, a sure sign of intelligent life on Earth. In a modern version of the Flaming Triangle, the Chinese artist Tsai Guo-xiong ignited a 10,000-meter-long gunpowder fuse extended from one end of the Great Wall of China. He called the installation Project for Extraterrestrials. Tsai's work reinvents the partnership of fireworks and exploration. But for sending real messages through space, radio communication works better. Radio can carry words, numbers, and pictures cheaply and at the velocity of light. The almost miraculous speed with which radio carries messages prompted even the earliest pioneers of radio technology to imagine using this wonderful new device to communicate with other worlds. Guglielmo Marconi, inventor of radio, picked up what he thought might be radio pulses from space. Nikola Tesla claimed that he too had received extraterrestrial signals. Tesla generated powerful electrical bursts at his laboratory in Colorado Springs and fancied that the resulting radio noise could be received on other planets. These imagined receptions were replaced by the real thing in 1931, when a Bell Telephone Company engineer named Karl Jansky accidentally detected the radio energy emitted naturally by clouds of hydrogen gas in the Milky Way. Grote Reber, an amateur radio enthusiast, then built the world's first true radio telescope. A metal dish 31 feet in diameter in the backyard of his home in Wheaton, Illinois, and used it to map the Milky Way. Today, radio telescopes record the murmur of interstellar gas clouds, the pulses of rapidly spinning neutron stars, and the screams of colliding galaxies. We humans have been inadvertently broadcasting to the stars for decades. The program you're watching is one such broadcast. It will reach the planet Saturn in an hour and a half and continue on into deep space. A sphere of radio and TV broadcasts surrounds our planet. Its radius is nearly 100 light years and is expanding at the speed of light. A 1,000 stars lie in the sphere of radio and television broadcasts that have leaked into space from Earth. And if there are any listeners out there, they could, in theory, intercept these broadcasts. The farther they are from us, the older the news that they're receiving. Alpha Centauri is a star only 4 light years away, so Earth's broadcasts reaching Alpha Centauri today are only 4 years old.
So brother, have you wondered about the human race? We're part of the continuum of time and space.
The star Capella is 40 light years away. So if anybody's listening there, the latest music they're hearing from Earth are the hits of the 50s.
Just take my baby dancing on a Saturday night.
The golden age of jazz is just dawning at Beta Pictoris, a star that shows evidence of having planets forming around it.
Sweet one, so mild, you're my golden child.
If there are any radio buffs at Mizar, a star in the handle of the Big Dipper, they're in a position to just about now be picking up Earth's very first radio broadcast.
Got a mighty fine show for you tonight. How y'all doing out there?
If we're leaking radio messages into space, the inhabitants of other planets, if they exist, might be doing the same thing. Large radio telescopes on Earth could detect such radio leaks from civilizations in nearby star systems, as well as stronger signals dispatched from planets thousands of light years away. This realization is the keystone of SETI, the search for extraterrestrial intelligence.
We're looking for signals from extraterrestrials, but we don't know where they're transmitting. Long waves, is it short waves? Is it microwaves? Is it infrared or optical? You can look at this problem and ask, at what wavelength is communication most efficient? At what wavelength is the background minimum? In a region of around 1 to 100 gigahertz, the galaxy is extremely quiet, and you can hear a pin drop. It's a very good wavelength region to communicate, and that's where this search happens to be operating. Here we are. Can we be the only ones? Implausible. In fact, in my humble opinion, impossible. 400 billion stars in our galaxy alone. Many of them undoubtedly have planetary systems, as we're just beginning to discover as we have the instruments to do it. 400 billion stars in our galaxy, 50 billion other galaxies. What are the chances in 400 billion stars, 50 billion galaxies, one intelligent civilization? And guess what? We're it. Completely impossible.
Some scientists doubt that there are any intelligent beings out there. One of their arguments is called Fermi's question. It's named for the Italian physicist Enrico Fermi, who asked, "Where are they?" His point was that technologically advanced aliens, if they exist, should have visited Earth already. Since they evidently have not, they don't exist. I performed an experiment to test the validity of Fermi's question. At home alone one night, I decided to have lobster for dinner. So I set a place, opened the door to the street, and waited for a lobster to show up and crawl onto my plate. Hours passed. At 11 p.m., I ended the experiment. No lobster had appeared, so I concluded there are no lobster on Earth. Since we know that lobster do exist, clearly there was something wrong with my reasoning. The error was, of course, that I'd failed to take the lobster's preferences into account. Lobster have their own agenda. They don't want to come to my house. But the fact that they don't show up doesn't mean they don't exist. As the SETI scientists like to say, absence of evidence isn't evidence of absence. Suppose we had an atlas that devoted but one page to each planet in the Milky Way galaxy. That's a lot of planets. Just a page once through all its volumes, glancing at 1 planet per second, day and night, would take 10,000 years. As the historian Thomas Carlyle said, contemplating the prospect of billions of worlds, if they be inhabited, what a scope for folly. If they not be inhabited, what a waste of space. At astronomical observatories like this one, on the island of Hawaii, astronomers are finding evidence of planets orbiting nearby stars.
We only want to know 2 things. What fraction of stars have planets, and what fraction of those planetary systems are similar to our own solar system? It wasn't until the early part of this century that it even became technically feasible to begin looking for planets around other stars. We want to do the star that's 4 arc seconds north.
Our technique involves watching a star to see how it is gravitationally pulled by its attendant planets. And an Earth-like planet is simply too small to yank around its host star. But a Jupiter, being some 300 times more massive than an Earth-like planet, does have enough gravitational oomph to yank its star around. And so for the moment, all we can detect are Jupiters and maybe Saturn-like planets. We watch the star night after night, month after month, and if the star does wobble, it must be doing so because a planet is pulling on it. It's a little bit like a dog owner having a little poodle on the end of a leash. The poodle, being very low mass, can still yank its owner around if the poodle goes around in circles. And in this case, the low mass planets can yank around the star. In the case of a poodle, of course, the leash is this leather tether. In the case of the planets, the leash is gravity.
Okay, Gary, after this star, we're going to go a little wacky. We're going to do one of these super bright B stars.
Moving to S122446.
Yes. We look for very teeny shifts in the spectrum that tell us that, in fact, the star is wobbling in space. It is moving alternately towards us and away from us. If the star is moving towards you, its entire spectrum will be shifted to the blue, and if the star is moving away from you, then the star will be shifted to the red.
Paul, we're on target.
Probably the most exciting endeavor that Paul and I are engaged in is the detection of additional planets to stars for which we've already detected 1 planet. And this would be very exciting, you see, because finding just 1 planet around a star seems not just lonely in the emotional sense, but it renders the system architecturally different from our own solar system, which of course has 9 planets. So the question is, are there other planetary systems out there with a plural that have multiple planets? And until we find one with multiple planets, we have not actually found kin of our own solar system.
The question of how we would detect life on another planet without actually going there is a really interesting one. There are some people, of course, who will only be convinced if we can actually image continents and oceans on another body. And that's an admirable goal, and that's where we eventually want to get to, for sure. But that's going to take a tremendous amount of technology development to get to that point, because there are vast distances between us and the nearest stars and their planetary systems. I mean, we're not there yet, but we are taking the steps so that we will have a picture in the next 10, 15, or 20 years of another planet that is as compelling as the Apollo 17 picture of the Earth in space.
Future telescopes operating in space could be linked together to create the equivalent of a lens larger than the Earth. Such orbiting observatories might be able to detect signs of life on the planets of nearby stars. Telescopes have incited speculation about extraterrestrial life ever since the summer nights 400 years ago, when Galileo first trained a telescope on the sky. Galileo, who lived just down the hill here, called the universe a great book, written in the characters of geometrical figures. This was a revolutionary idea. The books that mattered in Galileo's day were those written by the ancient authorities, people like Aristotle and Ptolemy. They said that the universe was a kind of nutshell with the Earth at its center, and the sun and planets were ethereal wafers pasted on the inside of the shell. In that kind of universe, there could be no life on other worlds because there were no other worlds. The stars and planets were like the decorations on the insides of the great cathedrals, beautiful, pristine, nearby, and almost perfectly useless. But when Galileo turned a telescope on the sky, he found that the planets and the moon didn't look like wafers, they looked like rotund worlds resembling the Earth in some ways. And when he looked at the sun, he found that it wasn't perfect, but besmirched by sunspots. Here's a sunspot here, this one's bigger than the Earth. As Galileo observed the sun here in Florence from week after week, he could see these sunspots, which are giant magnetic storms on the surface of the sun, moving across. Not the behavior of a flat, static object, but as we would say today, of a rotating ball of plasma, a star. Galileo's observations blew the roof off the universe. Aristotle, to the contrary, the Earth is not the only world, bound in a starry nutshell. It's one among many worlds, and there's no nutshell at all. The sun is a star, every star is a sun. The mathematical laws of nature that pertain here on Earth work everywhere else as well. And if there's life here, why not out there? Galileo's experiments touched off a scientific revolution that awakened humankind to the possibility of life beyond Earth. In Germany, Johannes Kepler identified the laws that govern the motion of the planets. Kepler found that the planets move faster when close to the sun and slower when farther away, in just such a way that their orbits always sweep out equal areas in equal times. This is a genuinely universal law, true of any object in orbit, from the moons of Jupiter to the planets of distant stars. In England, Isaac Newton showed that Kepler's laws result from the force of gravitation exerted by the Earth and every other massive object everywhere. It is by using Newton's equations that today's space navigators are able to put probes into orbit around Venus, Mars, and Jupiter. In the 20th century, Albert Einstein cleared up disparities in Newton's theory by composing a broader account of gravitation, the general theory of relativity. Relativity implied that cosmic space is expanding. The idea seemed so outlandish that Einstein himself rejected it, but big new telescopes were being built, and astronomers using them were able to identify individual stars in other galaxies and determine that they obey the same physical laws that pertain here on Earth. In 1929, the American astronomer Edwin Hubble, without knowing that relativity implied that the universe expands, discovered that the distant galaxies are indeed moving apart from one another, just as Einstein's theory had predicted. Less than 4 centuries after Galileo, humans had learned that the universe is all of a piece, expanding and evolving in accordance with one set of physical laws. Living creatures are made of the same stuff as are the stars and planets, and they obey the same laws. And so, in theory, life could exist all over the universe. There are more stars in the universe than there are grains of sand at the seashore. And our human desire to communicate runs so deep that we're willing to send messages even though we're not sure who might receive them.
Dear readers, what is life like on your planet? Do you have a pet?
Do you have any special abilities like zapping people?
Do you have any friends?
Do you speak in different languages?
Konnichiwa. Les étoiles sont les balles de gaz des fous.
Do you have wars?
Today we have the means to send messages to the planets of other stars. But is anyone listening? If we are to communicate with the inhabitants of other worlds, there must be creatures out there who have language, radio technology, and the ability to keep transmitting for centuries at a time, so that their signals can cover hundreds of light years of interstellar space. Yet we don't know how we learned to use language, or how long we may be able to listen for messages from the stars. If we understood how intelligence arose on Earth, we'd have a better idea of how often intelligence arises on other planets. The size of our ancestors' brains more than doubled during the past 2 million years, but nobody knows quite why. Somewhere along the line, about 50,000 years ago, human speech advanced from grunts and warning cries to the use of words as abstractions, capable of probing beyond the realm of immediate experience. In much the same way that prehistoric painters brought the daylit world into the darkness of caves, ancient poets painted word pictures of events remote in space and time. From that point on, evolution began to select not just for brute force and endurance, but for abstract intelligence as well. Nobody knows just when this happened or how. Until we do, it's going to be difficult to estimate how often intelligence has arisen on other planets. Once our ancestors could make sentences, they could make plans. In hunting and warfare, the balance began to shift from strength to strategy, with strategy tending to win out in the end. As Abraham Lincoln put it, force is all-conquering, but its victories are short-lived. Language is the key to communication. Symbolic language enables us to do mathematics, describe events that happened far away, and make a lasting record of our thoughts and feelings. If we're to communicate with extraterrestrials, they too must be able to manipulate symbols. To search for intelligent life in the universe is, therefore, to search for another species similarly endowed with an aptitude for symbolic language. Because if they don't have language, they may be smart, but we're not apt to hear from them. Creatures lacking a symbolic language cannot send complex messages through space or much of anywhere else. They can cry out in alarm or coo tenderly to their young, but they can't tell someone far away about their planet, their history, or their science. Indeed, without language, they can't have any real history or science. In that sense, looking for intelligent extraterrestrials means looking for beings rather like ourselves. Not that they'd resemble us physically, of course, or speak in a human tongue, but they would, by definition, have language. And where there's language, there's hope for translation. And with translation, an end, perhaps, to the long twilight of human loneliness, during which time we have known the delights and torments of being uniquely thoughtful, communicative, and self-aware.
Before language even, our artifacts becomes a shared means, inter-individual, by which we can accumulate knowledge of how to make our way in the world. I think that natural evolution of know-how in a co-evolving population of critters is probably going to be more or less expectable. Whether that leads to consciousness or language is quite another issue.
The main reason for considering intelligence as accidental is pretty clear. It's only evolved in one species after 4.5 billion years of the history of the Earth, which is about half the Earth's potential history if the sun's due to explode in 5 billion years or so. That's pretty amazing. There are only 4,000 species of mammals. We're a minor group. Consciousness has only arisen in one species, us, of a minor order of mammals, the primates, with fewer than 200 species in toto. You have 1 million named species, including about 500,000 of beetles. That is, if intelligence was such a good thing, and it was so obviously of Darwinian benefit, and it was an easy thing to achieve, I assume other lineages would have, and they haven't. And yet they're doing very well.
Is intelligent life merely an accident? Popular accounts of science often say so, claiming that life and intelligence are trivial. One scientist called life a fancy kind of rust afflicting the surfaces of certain lukewarm minor planets. Another portrayed humans as scum, a cosmic afterthought, clinging to a small planet in an uncaring universe. But there's a new vision on the horizon, one that sees intelligence as an emergent property, apt to appear on any planet that has a sufficiently complex biological system. The patterns formed by birds in flight and by schools of fish are emergent properties. They can be seen not in individual fish or birds, but only in large assemblages of them. According to this theory, emergent properties can be understood only by studying the system as a whole. The spiral arms of galaxies are fireworks shows created when brilliant young stars are formed by density waves moving across the galactic disk. Millions of stars must be born for the spiral pattern to appear. Weather is an emergent property. A low-pressure front is made of molecules of air and water, but we cannot perceive it just by looking at individual molecules. Only when we consider the system as a whole does it emerge as a thunderstorm. If intelligence emerges normally in the biospheres of living planets, as naturally as weather patterns emerge in their atmospheres, there may be many thinking beings on other worlds. Science traditionally has concentrated on the parts, the approach known as reductionism. But if intelligence is an emergent property, then it must be studied in the context of life as a whole. A group of musicians who've never previously played together are warming up before their first rehearsal. One musician begins playing a familiar composition. A few others recognize what it is and join in. But the composition becomes fully recognizable to all only when enough musicians are playing together for it to emerge. If intelligence emerged like this, as naturally as clouds gathering to make a storm, then thought may not be incidental to the workings of the material universe, but in some sense the point of it all, the central theme in a cosmic symphony. There's an Islamic saying that three things are known to no man: the hour of his death, the true name of Allah, or the source of his next meal. In the Jewish tradition, there's a story of a rabbi who's stopped after curfew by a Cossack who says, "Where are you going, old man?" And answers, "I don't know." The Cossack arrests him, and as the door to his cell slams shut, the rabbi says, "You see, I told you I didn't know where I was going." Which is pretty much our situation as members of an intelligent species who don't know if there are any other intelligent beings out there in the universe. We think it's good to be smart, that it bodes well for our destiny and should for other species too in other worlds. But we don't really know where we're going, do we? Does the fact that humans are intelligent mean that we're likely to survive? Or will we blow ourselves up or pollute the earth so badly that we can no longer live here? Richard Gott and Freeman Dyson are physicists who concern themselves with human destiny. So intelligence doesn't confer any particular propensity toward surviving longer or blowing yourself up sooner?
I think, unfortunately, just taking us as the example here, my guess is that it's similar. I mean, Albert Einstein, he was very smart, but he didn't live orders of magnitude longer than other people. So what we sort of learned is that smarter species don't tend to live longer than other ones. This is an unfortunate thing to notice. So one of the things we might like to know about is how long the human race is likely to last. And we can be helped in reasoning about this by using the Copernican principle.
Richard Gott has devised a formula for predicting how long the human species is going to last. He begins with the assumption that there's a 95% likelihood that we're living during the middle 95% of humanity's total tenure. To date, Homo sapiens have existed for about 200,000 years.
So there's a 95% chance that you're located in the middle 95% of human history, and that therefore the future longevity of the human race is likely to be longer than 5,100 years, but less than 7.8 million years. Now, those numbers are interesting because they give us a total longevity that's quite similar to other species.
All beings who have learned that the universe is old must also know that by comparison they are young. The longer alien civilizations typically last, the better our chances of communicating with them. The lights on this tree represent technological civilizations that might have arisen in a given galaxy over a period of 1 million years. The length of time that each light stays on represents the period during which each civilization is willing and able to make radio contact with the inhabitants of other such worlds. If the communicative worlds typically stay on the air for 500,000 years, their persistence is rewarded. Each finds that it has plenty of contemporaries with whom to make radio contact. So if civilizations last a long time, SETI, the search for extraterrestrial intelligence, is a cinch. But watch what happens if alien civilizations typically last only 100,000 years before they become extinct or lose interest. Now they find that there are only a few worlds on the air at the same time they are. And if they're typically on the air for only 100 years, then each finds itself almost certainly alone. 100 years is longer than we here on Earth have yet been listening for signals from the stars. So SETI requires that alien radio buffs stay on the air a lot longer than we have. The great void in interstellar communication is not space, but time. There may be creatures out there who live as long as sequoias and reside in cities older than the pyramids, but on the cosmic time scale, even those civilizations are fleeting as fireflies, brief flickers in a wheeling galaxy. What monuments might they have built to leave some trace of themselves in the annals of cosmic history? Perhaps they long ago established a permanent network to link inhabited planets and preserve a record of their histories. If so, the first signal we receive could come from an interstellar internet. Deployed over eons by robotic spacecraft, such a network could bring libraries of information within relatively close reach of emerging worlds like ours. Communication can bridge time as well as space, revealing the histories of societies that disappeared long ago, and offering clues to how our species might best navigate its way toward the dim and distant future.
I mean, a species, generally speaking, lasts a few million years. That's sort of typical of a species. And if that's true of our species, well, that's fine. We're in good shape for another million years or so, and that would be plenty of time for most people. However, the whole idea of species is fading away as soon as you have genetic engineering and genes being transferred from one species to another, which is already happening.
But Homo sapiens, unless you think of them as abdicating or genetically re-engineering themselves until they're unrecognizable? Or?
Yes, I think that we shall probably become many different species, if we are species at all, in a time that's much shorter than these 2 million years that you're talking about. And there's just a huge difference between 100 years and a million years. In 100 years, we'll be the same as we are, but in a million years, probably not. Mm-hmm. So we can imagine over billions of years, intelligence has grown and developed far beyond any sort of intelligence we now have, and that it might, in fact, become a major player in the physical development of the universe, reorganizing galaxies to move immense quantities of matter and radiation from one part of the universe to another. We might, in fact, become creators and producing a universe in which we can live forever. That's at least a dream, which is not altogether pointless to think about.
We don't know how many alien civilizations exist, or how long they typically last, or how many of them take the trouble to broadcast signals. What if everybody's listening and nobody's sending? Scientists involved in SETI hardly ever transmit anything, either because they'd probably have to wait decades or centuries to get an answer, or out of fear of betraying our presence to aliens who might, for all we know, be hostile toward us. But what if someday we did want to send a message, a powerful message beamed to a planet where we had some reason to expect there was somebody listening? What would we say?
I want to know if they're bad guys or good guys. If they're good, we can work with them, right?
Dear extraterrestrial, please respond to this message by sending a radio signal back on the frequency at which you receive this message, making due allowance, of course, for your motions around your star. Send that signal at a power level such that it arrives on Earth with at least 10 to the minus 23 watts per square meter. And leave your transmitter running long enough, let's say a few months, so that one of the searches now operating on Earth will receive it. Then we can really get a conversation going.
I would say, please forgive us for making so much noise. But talking is what we do all the time, and maybe the reason we don't hear the aliens is because they are different and they keep quiet.
What an awesome, self-unfolding, miraculously generative universe we are fortunate enough to share. That's what I would say.
What I want to know from you is, what's your biochemistry? I really want to know whether life has to be done through DNA or whether there are lots of other ways, and I need another experiment to find out. And the other thing, I will give to you the B minor mass, because that's the best thing we've ever done. But I'd like to know whether you've ever done anything that beautiful, and if so, what was it, and share it with us.
Our intelligent species has been around for 200,000 years, and we have sent members of our species to our neighboring moon. And we've learned something of the laws of physics, and we've learned where we are in the universe. How are you doing?
Greetings from one of the species that inhabit Earth, a blue planet orbiting an average star. We call ourselves Homo sapiens, by which we mean that we're capable of mathematics, science, and the technology by which this message is being sent. We're the only such creatures on this world, and so far as we know, the only ones to have lived here throughout its long history. Science has brought a better life for millions of us, but many more of us still live in poverty, tyranny, and ignorance. Sometimes we wonder if there's intelligent life on Earth. We've only just glimpsed the vastness of time and space and of our own ignorance. We've learned that we have a lot to learn. And so we're dispatching this message in hopes of learning something about you and about ourselves. We request the favor of a reply.